73 seconds to silence. The shuttle has cleared the tower. The crowd cheered. Children waved flags. Teachers held back tears of pride. The countdown had ended, and history had begun. At exactly 11:38 a.m. on January 28, 1986, the Space Shuttle Challenger rose into the cold blue sky from Cape Canaveral, Florida. Aboard were 7 astronauts, scientists, engineers, pioneers, and one civilian teacher, Christa McAuliffe, chosen to inspire an entire generation. But 73 seconds later, everything went silent. On live television, millions watched as the shuttle disintegrated in a fireball, arching into a jagged trail of smoke that split the sky. It looked almost poetic. Until you realized what you were seeing. A national triumph had become a national tragedy, and no one could explain why. But what if we told you? This wasn't an accident. This wasn't unforeseeable. And the most disturbing part? They knew. What happened that day wasn't just a mechanical failure. It was a collapse of courage, of conscience, of a culture that chose image over integrity. This is the story of what really happened behind the headlines. The stories NASA hoped the public would forget. The desperate engineers who tried to stop it. And the haunting clues that suggest some of the crew may have survived the explosion, long enough to know they were falling from the sky. This isn't just a history lesson. This is a warning. And it all begins with the dream that turned into a lie. The dream and the illusion. To understand the Challenger disaster, we must first understand what it represented. The 1980s were an era of ambition, and no symbol captured that more than NASA. The Space Shuttle program was marketed as the next great leap in human progress. Reusable spacecraft that could carry satellites, equipment, and even civilians into space, again and again, like commercial airliners. NASA called it the future of space travel. And Challenger was at the heart of it. By 1986, Challenger had already flown 9 successful missions. It was celebrated, photographed, and even romanticized, sleek and white, a spaceship made of steel, software, and American pride. But the launch on January 28th was different. Because this time, a teacher would be on board. Her name was Christa McAuliffe, a high school social studies teacher from New Hampshire. Selected out of more than 11,000 applicants for NASA's Teacher in Space program, Christa was the embodiment of a dream. That anyone, even a civilian, could go to space. She wasn't a scientist. She wasn't military. She was a mother, a wife, a believer in education. And America fell in love with her. Students across the country were told to tune in. Schools wheeled televisions into classrooms. NASA didn't just want to make history, they wanted to inspire it. The launch was timed to maximize public visibility. The eyes of the nation were watching. But as the media spotlight intensified, the cracks began to show. And I'm not speaking metaphorically. Because behind the scenes, actual cracks were forming. Hairline fractures. Warnings. A weather report no one wanted to read. Engineers who couldn't sleep. Meetings where silence replaced truth. They wanted the world to see courage. But all it would take was one fatal flaw, and the illusion would shatter. And that's when the first red flag surfaced, and it was ignored. The O-ring warnings. The night before the launch, a small group of engineers were in a state of quiet panic. Among them was Roger Boisjoli, an engineer at Morton Thiokol, the contractor responsible for building the shuttle's solid rocket boosters. Boisjoli wasn't a headline figure. He wasn't in a NASA press briefing or at a launch party. He was in a dimly lit conference room, poring over temperature forecasts and design schematics. And what he saw terrified him. The forecast predicted record-low temperatures for Florida, as low as 18 degrees Fahrenheit on the launch pad. That might sound mild in some parts of the country. But for the rubber O-rings used in the shuttle's solid rocket boosters, it was catastrophic. These O-rings were crucial. They sealed the joints of the rocket boosters, preventing hot gas from escaping and igniting the fuel externally. They were made of a synthetic rubber compound, flexible under normal conditions, but dangerously rigid in the cold. Boisjoli and his team had seen this before. In previous missions, the O-rings had shown signs of erosion and burn-through, even under warmer conditions. There was no doubt in his mind, if Challenger launched in such cold temperatures, the O-rings would fail. That night, Morton Thiokol engineers gathered for an emergency teleconference with NASA officials. Boisjoli and several of his colleagues urgently recommended delaying the launch. They presented charts, field data, and graphs. Their message was clear. If you launch tomorrow, this vehicle is going to blow up. But instead of listening, NASA pushed back. Some at NASA argued that the data was inconclusive. Others suggested the engineers were overreacting. The pressure to launch was immense. A top NASA manager reportedly said, "My God, Thiokol, when do you want me to launch? Next April?" Then something deeply disturbing happened. At one point in the call, Morton Thiokol's senior executives asked the engineers to leave the room, and in private, reversed the recommendation. They told NASA the launch was a go. Boisjoli was stunned. He later described it as the most unethical decision he'd ever witnessed in engineering. And so, against the advice of the very people who built the shuttle's boosters, the countdown began. Christa McAuliffe went to sleep believing she'd become the first teacher in space. Her students prepared to watch history. The engineers who tried to stop it were silenced. And outside, the Florida night dropped below freezing. Frost formed on the launch pad. Ice coated the shuttle's external fuel tank. The rubber O-rings shrank. And no one could stop the clock. But what happened next would silence those warnings forever. Politics, pressure, and deadlines. To the public, NASA was a beacon of brilliance. Scientists in lab coats, astronauts in flight suits, soaring boldly into the unknown. But behind the curtain, NASA was under pressure. Not from science, but from politics. The Challenger launch had already been delayed 6 times. Technical issues, weather problems, scheduling conflicts. Each postponement had rippled through NASA's calendar and dented their public image. The Reagan administration was eager for a win. The shuttle program had become a symbol of national pride, and President Reagan was scheduled to mention the Challenger launch in his upcoming State of the Union address. This was meant to be a feel-good moment, America reaching for the stars, led by a teacher who represented every classroom in the nation. And in that culture of optimism, bad news was not welcome. NASA managers were caught in a dangerous trap. Delays meant more than inconvenience. They risked funding, media criticism, and political fallout. The message, unspoken but deeply understood, was this: stay on schedule or face the consequences. Internally, this created what safety experts now call normalization of deviance. A mindset where small risks, erosion on the O-rings, temperature variations, were no longer treated as alarming, but simply as acceptable margins of error. In other words, NASA had begun to treat danger as routine. Even more chilling, the shuttle was not nearly as reusable or safe as the public had been led to believe. Internal documents revealed a staggering pattern. Corners were being cut. Communication was breaking down. Managers had started making engineering decisions without understanding the technical risks. When engineers raised concerns about the cold weather, they weren't met with curiosity, they were met with resistance. One NASA official reportedly accused Morton Thiokol of being too cautious. But the engineers weren't being cautious. They were trying to save lives. And yet, in the early hours of January 28, 1986, the launch was confirmed. Challenger would fly. No matter the risks. No matter the temperature. No matter the consequences. As dawn broke over Cape Canaveral, the ice still clung to the launch pad. A frigid wind whipped across the Florida coast. And the people tasked with protecting the astronauts stayed silent. Because they had a deadline. Because they had pressure. Because saying no meant defying a machine much bigger than themselves. And then came January 28th, a morning colder than anyone expected. The launch and the final seconds. It was just after 11:30 a.m. when the Challenger rolled out onto Launch Pad 39B. The morning was bitterly cold. Frost glistened on the tower. Steam curled from the shuttle's base. Technicians wore heavy jackets, and reporters stamped their feet to stay warm. It was the coldest launch in NASA history. But the countdown didn't stop. At 11:38 a.m., the massive solid rocket boosters ignited. Challenger lifted off with a roar that shook the ground and sent ripples across the Atlantic. The crowd cheered. Parents cried. Christa McAuliffe's students leaned closer to the screen. For a moment, everything felt perfect. The shuttle climbed steadily into the sky, a column of flame and smoke trailing behind it. Aboard were 7 astronauts. Francis R. Scobie, Commander. Michael J. Smith, Pilot. Ronald McNair, Mission Specialist. Ellison Onizuka, Mission Specialist. Judith Resnick, Mission Specialist. Gregory Jarvis, Payload Specialist. And Christa McAuliffe, Teacher and Civilian Payload Specialist. They smiled, unaware that beneath them, something had already gone fatally wrong. Right at liftoff, the freezing O-rings in the right solid rocket booster failed to seal. A small flame began to leak out, invisible at first, but deadly. By 58 seconds into the flight, the flame had begun to burn into the adjacent external fuel tank. 73 seconds after launch, flight controllers noticed a sudden, chaotic burst on the monitors. The shuttle had veered violently off course. At 11:39 a.m., Challenger disintegrated in mid-air. A fireball bloomed in the sky. Debris spiraled outward in twisting white trails. The silence that followed was louder than the explosion. At first, many in the crowd clapped, thinking it was part of the spectacle. But within seconds, horror dawned. On live television, millions of Americans had just witnessed the death of 7 astronauts. Teachers, scientists, parents. A nation held its breath, and then broke into tears. But here's the detail that most people don't know, and it's the one that still haunts experts to this day. They may not have died instantly. The unthinkable reality. NASA's initial assumption was that the crew perished the moment the shuttle broke apart. But when the crew cabin was recovered from the ocean floor, investigators found evidence of survival. At least 3 emergency air packs had been manually activated. The pilot's personal switch was flipped to an emergency setting. Some helmets were still in place. This chilling evidence suggests that some of the crew were alive and conscious after the explosion, possibly for the entire 2-minute and 45-second descent before the cabin slammed into the ocean at over 200 miles per hour. No one can say for sure what they saw, or what they knew. But in those final moments, they may have realized the truth. The silence wasn't from space. It was from Earth. Because what killed them wasn't a star or a comet or a black hole. It was a choice. But what's more disturbing is what the investigation uncovered and tried to hide. The cover-up and the Rogers Commission. In the aftermath of the explosion, the country entered a state of collective mourning. Schools held moments of silence. News anchors struggled to find words. President Reagan canceled his State of the Union address and instead delivered a national eulogy. The future doesn't belong to the faint-hearted. It belongs to the brave. We will never forget them. But while America grieved, behind closed doors, NASA scrambled, not just to investigate the cause, but to control the narrative. Almost immediately, the blame began to shift. NASA officials downplayed mechanical failure and implied that something unpredictable, some random, unforeseeable tragedy, had occurred. But there were whispers within engineering circles that didn't match that story. Engineers like Roger Boisjoli were telling colleagues they had warned NASA in advance. And others started asking a very uncomfortable question. If they knew, why did they launch? To manage the growing pressure, President Reagan established the Rogers Commission, a high-profile investigation led by William P. Rogers, former Secretary of State. The panel included astronauts, scientists, military figures, and, crucially, a Nobel Prize-winning physicist named Richard Feynman. Feynman didn't play politics. He wanted the truth. And what he uncovered shocked even him. NASA's culture of silence. Testimony after testimony revealed a culture inside NASA that prioritized image over safety. Engineers who raised concerns were routinely ignored, and data that contradicted optimistic launch estimates was either buried or dismissed. One manager reportedly said, "We had gotten away with it so many times before, we just thought we could keep getting away with it." In a stunning moment, Feynman, during a televised hearing, dropped a piece of O-ring rubber into a glass of ice water. Within seconds, the rubber lost its flexibility. He pulled it out, held it up, and let the country see what NASA already knew. Cold kills flexibility. Inflexibility kills seals. And broken seals kill astronauts. The room fell silent. Feynman later wrote in his appendix to the Commission's report, "For a successful technology, reality must take precedence over public relations, for nature cannot be fooled." His words cut through the fog like a knife. But even after the dramatic hearings, even after the ice water demonstration, even after it became undeniably clear that NASA had been warned, the agency still hesitated to accept full responsibility. Their excuse? The data wasn't conclusive. But science is rarely conclusive. Engineering is about probabilities, not guarantees. And those probabilities had been red-flagged again and again, before Challenger ever left the pad. What the Rogers Commission ultimately revealed was not just a failure of hardware. It was a failure of integrity. And then came the memo no one was supposed to see. The memo that could have saved them. It wasn't just words said in meetings. It wasn't just vague concerns. There was a paper trail, and it was damning. Months before the Challenger launch, engineer Roger Boisjoli had written a formal internal memo to his supervisors at Morton Thiokol. The subject line was stark. Help! The O-rings are going to fail. He warned that the seals were becoming brittle in cold weather and that a failure was not only possible, but likely if temperatures dropped. The result could be a catastrophe of the highest order, he wrote. Loss of human life. This wasn't some casual backroom conversation. It was a documented, time-stamped alarm, delivered directly to those responsible. But it was buried. His managers acknowledged receipt, and did nothing. When Boisjoli and his team tried again, this time just hours before the launch, they were shut down once more. In fact, after his objections, he was told to take off his engineering hat and put on his management hat. Translation: stop thinking about safety. Start thinking about optics. After the disaster, Boisjoli was devastated. He didn't sleep. He didn't celebrate being right. He grieved, publicly and privately. Because for Roger Boisjoli, it wasn't just a professional failure. It was a moral one. He would later testify before Congress, revealing what had been hidden, not just a flaw in rubber, but a flaw in the system. In a haunting interview, he said, "I fought like hell to stop that launch. And I failed." He became a whistleblower. He lost friends. He was ostracized by his company. His career as an engineer, effectively over. But his conscience, intact. The Boisjoli memo became one of the most important documents in the history of American engineering, taught in ethics classes, studied in business schools, referenced in NASA reforms. It was proof that truth was spoken, that someone did try to prevent it, and that the system chose silence over safety. But even after the deaths, the system refused to change. The aftermath and the survivors' families. In the days following the disaster, America mourned. Flags flew at half-staff. Schools held memorials. Newspapers printed photos of the 7 smiling crew members, frozen forever in time, not as astronauts, but as fallen heroes. But for the families left behind, mourning quickly gave way to something darker. Questions. Why were they told the launch was safe? Why were O-ring concerns kept from the public? And why, in a program built on engineering excellence, were preventable risks ignored? The families of the astronauts didn't just want closure. They wanted answers. Some, like June Scobie Rogers, widow of Commander Francis Scobie, became outspoken advocates for truth and reform. In interviews, she pressed for accountability, not revenge. Her message was clear. We're not angry. We're heartbroken. And we want it to never happen again. Others remained silent, shattered by grief. Parents, children, spouses. Many struggled not only with loss, but with the way their loved ones died, broadcast live to millions, turned into symbols before they were even laid to rest. Meanwhile, NASA began a public relations campaign. They assured Americans the shuttle program would continue. They released memorial pins, educational materials, and documentaries about courage. But critics and families weren't impressed. They didn't want inspiration. They wanted change. In 1988, over 2 years later, NASA returned to flight with a redesigned shuttle and new safety protocols. The agency claimed it had learned its lesson. But some insiders weren't convinced. In fact, whispers inside the agency suggested that the culture hadn't changed, only the language. And the most painful proof of that would come again in 2003. Because 17 years after Challenger, another shuttle, Columbia, disintegrated on re-entry, killing all 7 aboard. And once again, the warning signs had been ignored. And once again, Managers had silenced engineers. Challenger's legacy wasn't a memorial statue. It was a blueprint for how not to lead, how not to listen, how not to manage human lives like political capital. But hidden inside this tragedy is a story most people never hear, about the crew themselves, and what they knew. What the crew knew, and the evidence they may have realized the truth. For years, the public was told a simple narrative. The Challenger exploded, the crew died instantly, and there was no pain, only a flash. But as the investigation deepened, unsettling evidence began to emerge, suggesting something far more haunting. Let's go back to the moment of disintegration. The shuttle itself didn't explode in the traditional sense. What actually happened was a structural breakup, a violent, uncontrolled failure of the vehicle. The external tank ruptured, releasing a massive plume of liquid hydrogen and oxygen that ignited in a fireball, but not in a way that instantly vaporized everything. Instead, the crew cabin remained intact. It was violently ejected from the main fuselage and continued upward, arcing through the sky, before beginning its long, silent fall toward the Atlantic. And that's when the most chilling clues appear. Investigators later recovered the wreckage from the ocean floor. Inside the crew cabin, they found 3 personal egress air packs, PEEPs, small emergency oxygen systems, had been manually activated. The pilot's emergency switch had been thrown, a deliberate action that could not have occurred by accident. Crew members' helmets were still fastened. Control panels showed signs of post-breakup input. These details paint a haunting possibility. The crew didn't die in the explosion. They knew. They had between 2 to 3 minutes of consciousness, falling from the sky, trapped in a sealed capsule, with the entire Atlantic Ocean racing toward them. Think about that. 2 minutes of weightless silence. 2 minutes of knowing something had gone terribly wrong. 2 minutes of trying to stay calm. 2 minutes of maybe saying goodbye. No alarms. No engines. Just the sound of their own breath and the creaking metal of a dying ship. NASA has never officially confirmed how long the crew survived. The agency has stated that there was no way to know what they experienced, and that oxygen packs don't necessarily indicate consciousness. But among engineers, investigators, and the families, the suspicion remains. The astronauts were trained to problem-solve under pressure. They were professionals, heroes, and in their final moments, they may have tried, against impossible odds, to regain control, to survive, to do what they had been trained to do. But the system failed them. Not the physics, not the fuel, the people. And perhaps the cruelest irony of all? The teacher who was meant to inspire a generation died for a lesson the world didn't want to learn.